Hi everyone, and welcome to Ungalkaga Physics. And in this video, I will be introducing the concepts of uh, units, right? So, what is meant by unit is how it play an important role in solving problems, right? And we will do dimensional analysis, right? So, both are in sense both are similar, but you have to know some nuances, right? That's it. And come on, let's get into this. What is in by units? What are the types of units we have, right? Those things we are going to discuss in this video. So let's discuss what is in by units. Okay. So if you are making any measurement, right? It is obviously that's a physical quantity. Say mass, meter. Okay, those things are some physical points in physics point of view, right? So if you are measuring the mass, okay, if you are measuring a mass here, if you measure a mass in some other place, it should not vary, right? So those measurements have some standard values. If you are measuring 1 kg, it should be 1 kg in all the places, right? So those standards are arbitrarily chosen. Okay, those are internationally accepted. You take 1 kg here, if you place it at that 1 kg at somewhere places, it should measure 1 kg, right? And it with a certain basic. It is not available naturally, but these things are man-made standards, right? But it is followed everywhere, right? So in examinations, try to remember that SI units are used uh, in most of the cases, right? If you are solving any problem, if you are getting any answer, check with the option whether you solved that problem in a SI unit or not, right? So the units may differ. For example, if a problem contains mass, okay, mass of say 10 gram and length of 2 meter, okay, so you have to convert all the inputs into standard international units, okay, right? So these things you have to remember, right? In units we have two types of units. First one is the fundamental unit, right? And second one is the derived units. The fundamental units which create a base, right? So without that you can't write derived units, right? So the units of all the other physical quantities can be expressed as a combination of base units. Okay. In the case of mechanics, we use MKS system here, okay, which is nothing but meter, kilogram, second system. Okay, so these are this MK system, which is the SI. These are the SI units. For length, we have meter, and for mass, we have kilogram. For time, we have seconds. Okay, so these are the fundamental quantities which are used in mechanics. Right? These are fundamental quantities. Let me explain with the help of these fundamental quantities what is meant by derived quantities, right? So we have a derived quantity. Okay, we are going to derive a quantity with the help of length, mass, and time units. That is meter, kilogram, and seconds, right? So let me remember a formula of for velocity. V is equal to displacement by time, right? So V is nothing but displacement by time. Okay. Displacement is nothing but some sort of length, right? So it is measured in meter, and time in SI units we measure it in seconds. So the unit of velocity is nothing but which we derived from the fundamental quantities, which is nothing but meter per second or meter second power minus 1, right? And second example which I used to give is acceleration, which is nothing but velocity by time, right? So velocity is nothing but meter per second, right, or meter second power minus 1, and time is nothing but seconds. Ms power minus 1, here we have s, and if I take this s from the denominator to numerator, it would become ms power minus 2, right? Then I will give another example. F is equal to ma, which is Newton's second law. M is the mass. The SI unit of mass is kilogram. Acceleration already we know, meter second power s power minus 2. So this is a derived unit. In general, the force is measured in terms of or given in terms of Newton for the honor of Sir Isaac Newton. Okay. For Newton, the SI units, the fundamental unit can, sorry, the Newton can be written in terms of fundamental units, which is kilogram meter second power minus, right? So this is all about the units. The thing is, you have to remember formulae. Okay, the formulae for all the physical quantities are very important. Okay, if you remember formulae, you are able to write the units of that physical quantity. Say momentum, say force, say energy. Those things can be written with the help of formula itself, right? That's why formulas are very important, right? So next we will get into dimensions. There are dimensions of physical quantities, right? So there are a lot of things to discuss. Initially, we discuss with the help of SI units, right? So particularly for mechanics. Right? So dimension of a physical quantity are the powers to which the base quantities are raised to represent the quantity, and the dimensions are expressed by using square brackets. Okay, square bracket, it should be like this, right? So far we discussed uh, basic units. Those are fundamental units, which is nothing but the length and mass and time. Okay, which is nothing but the length, just measured in meter. So don't confuse with the small m with the capital M, right? That is more important. So kilogram, which is the SI unit, time is the seconds, right? So kilogram, meter, second, this can be written in a form of a dimensional quantities like this. It is given in a square brackets. Okay, for example, if I want to write a dimensional quantity of a length, okay, length, it can be written like this, right? For distance, displacement, those things are length. Okay, so we can write L in a square bracket, or more generally we can write it as m power 0, L power 1, and t power 0, the combination of three fundamental dimensions. Okay, this is the more convenient way of writing the dimensional quantities. Okay, dimensions of physical quantities. For say mass, okay, you can write it as capital M. Don't confuse with the small m, right? So we can write it as m power 1, L power 0, t power 0. Now we can write it for velocity. The dimensional quantity of velocity, obviously velocity is a derived quantity, right? So which is nothing but displacement by time. We can write it as displacement is nothing but length, and time obviously, which is t, and the dimensions of velocity we can write in this format as m power 0 because there is no kilogram there. Okay, and L power 1 in T power minus 1. And this is the way of writing the dimensional quantities for the given physical quantity. And for this also, you have to remember form. Okay. In all the units, if you are seeing any new equation, okay, you have to know what are the terms are, what are the units of the terms are, and you have to do this dimensional analysis for each and every physical equation, right? That will make you to practice more and try and it will help you to get rid of the mistakes, right? So using this physical quantities and fundamental units and derived units, in next video we will discuss some problems. Happy learning, stay safe and stay positive.